So tonight and it's not the last session, but the last session, it's not the serious one. This is the session with Paulo Rodrigues from QMENTA. He will talk a bit about the QMENTA platforms and about why we all need containers, but some of us still pretend that we don't. And it's a good chance to see if any of your projects can benefit from running on cloud, and if you want to give reproducibility / open workflows taste at your project. And I will start recording. So Paulo, whenever you want, you can start.
Yeah, okay. So, whoop, you see my screen, right?
Yeah.
So, yeah, thank you so much, Mateo, for the introduction and invitation to to add our little grain of salt to the challenge and to the Brainhack, in fact. And as you well said, now there's today I'm gonna be speaking about how we are using Docker and containers, and like how that is attached or parts or one of the pieces of what we call the QMENTA platform. So like this cloud infrastructure to really help in scaling and optimizing and distributing imaging workflows. So like, I'm sure that everybody in the hack is super excited in running and contributing to the different projects, but there's also challenges, and that's what I'll be talking today, how we are tackling some of these things. Well, I'm not in the Atlantic Ocean. I'm calling from Barcelona, so it's like from the Mediterranean Sea, but it's near enough. So that's also okay. So I'm going to be talking a little bit about, there's lots of hype and there's lots of activity in AI and medical imaging AI, especially in neuro as well, CNS, but other medical applications. But there's some challenges, as we all know, and a part of that is not only related to training and building your algorithms or computational tools, but then also how to make them easy to use, because in the end, everything that we are doing and everybody here is doing is like figuring out how to make a best model, or how to make or how to create the most reproducible method for cryptography or for something else. But then that's great, and you can share the code on GitHub and publish that. But then for somebody to use it, there's a bunch of challenges. So that's why we use Docker as a way to make all this process easier. And then some examples, or basically some links and some information on how you can share your code through this way that we're helping also like with different challenges out there and Brainhack. And then in the end, like I'm not gonna take lots of time, so then there's plenty of time to talk about ideas or different projects and how we can help with the cloud infrastructure and Docker as well, how it can help maybe some of the projects. Yeah, so coming back to the topic, right, like in building computational tools or AI, to call it like in broad names, so like a way to look at it, right, is there's typically a use case or some question, but there's a lot of effort in this initial part in preparing the data, accessing the data, preparing it, anonymizing it, labeling it, curating, is it good quality or not. Then you take those images, that data, and actually build or train your model and repeat and repeat and repeat. And in all this process, there's lots of issues dealing with data, managing it in a way that, by the way, because it's all healthcare, is also to be compliant, right? That has to be anonymized, or GDPR in Europe or HIPAA in US. There's lots of challenges also there. And there's a lot of time and effort and energy in a way spent in dealing with data engineering and preparing data for the different models, or the different machine learning, or the different techniques or tools. Then if you take that further, you have a great algorithm, you potentially want for it to be used in clinical care, right? So there's like the FDA getting regulatory approval, but even not considering the FDA or like the clinical use or the clinical usage of some of these tools, even just you build a model, you build a tool, and then you want somebody else to use it, right? There's there's issues because the users in many of these cases are clinicians, are not like so much engineering savvy or tech savvy kind of profiles, and that, which is totally fine. But you want that your tools are distributed, and actually the great algorithm that we created is easily used by psychologists or clinicians or the different like clinical partners in the projects, in the studies. And there's a big challenge there as well, that is how to make that accessible and easy to use by these kind of profiles, right? Like in almost like embedded, if you will, in their workflow, how to make this code and these tools interoperable. And there was like this nice phrase or this nice quote from this guy from Google, that there's a sure, one thing is like you're making all the effort in and proud to create an algorithm that is now super important, and it's to have it right, to have the best results. But besides that, also is like as critically important that algorithm is, that this fantastic tool is validated, but is embedded. It's part of the radiologist or the clinician's workflow. So like how to make, there's one challenge in creating and building the tool, technical and data challenges, but it is like how to make that tool available and to be run or used by the end users in this case, right? So the way that we, let's call it democratizing, like the way that we use is like, well, we, suffering or having suffered also like these issues, we basically, it's very easy the way to use the platform. So like this cloud platform, the QMENTA platform, and Docker. So on one side, the developers can use Docker and easily push their code into like a Docker hub, into a register. So like they share the code into these executable containers. That becomes available as an option, like kind of a drop-down list of potential tools that any user can run. So like they attach they plug in a way, developers can plug in the tool into the platform, and then the end user, might be the developers, might be the brain hackers, might be a clinician. They simply use the web interface and then apply that latest algorithm that was just published. They can run that algorithm just with a click of a button of an option, and apply that, run that into the data that they just uploaded, and everything gets scaled automatically in the cloud. So all this effort of technical moving data around and executing Dockers and all these things, like it gets pretty much straightforward, almost like off the shelf kind of thing. And so I'm gonna come back to that, like how everything fits together. But maybe because part of the audience probably heard about Docker, some quick intro, like what is Docker, like what's the difference with the typical way of doing things, like starting with the typical way of building or developing. Like you have your operating system, right? That there's you can code and you can write your code and run things in your laptop, in your computer. But the challenge comes where when then you want to make that code available, or make that tool, that thing that computes some results, to share that. The way that you do it is share your code, you publish it on GitHub, and then somebody on the other side of the world needs to download that code and try to figure it out, how it works, how to make it work, how to run your Python script or your Bash or your MATLAB, what are the parameters, and then maybe also your system is different or different version, or you have different libraries in your own system, and there's like lots of headache normally in getting all these environments that you need to run your algorithm to make it. So all the libraries, you need to also like take lots of care about that and waste energy in doing that. But the point here with the operating system, like with like a single machine, is like you have different applications that share a common set of libraries that you have installed in your computer, and that has, it's maybe effective in some sense, but then it becomes very difficult to share and to collaborate with that respect. I kind of skipped a step. There's also like virtual machines. So like you are not bounded by your hardware, but you can have virtual machines, even locally, but also like in a cloud environment, like Google Cloud Platform or Amazon Web Services. So in a way, you have a snapshot of so virtual machine, right? Like your operating system, like you have that virtual computer in the cloud that you can access. So you can have different versions or have like different instances of different virtual machines already like with pre-installed libraries, or you set up your development environment, execution environment. It has some advantages. You're not binded by the hardware. You can replicate that easily, so you can it's a step further in having in running like studies where we would run, imagine different free surfers, so you could scale, you can start different virtual machines and and do it kind of launch this free surfer in the different virtual machines, so it's like easier to scale, but still you have the issues with sharing the code. And then containers, where you come to containers, like you probably, I'm sure you're familiar with Docker or LXD or other Singularity and other systems, where basically it's like you have like the containers like this smaller kind of image. So a set of basically it's almost like data is like a series of files, or a set of files, let's say, that inside it runs on your computer in different systems, but like inside it you can add like different layers, like you can configure, have smaller, like imagine like little virtual machines that you add the libraries and the code and different things, so like your applications, and then you can really have an isolated like this container, like basically like a little image, so that you have that you can move around easily. It's much more flexible than other systems, not as flexible as virtual machines for some security aspects, but figure that out. But it's very easy to ensure great performance, isolation. It's easy to maintain. You can have versions. You can share like some files, the Docker files, like to create, to launch this kind of like your version of a computer and install everything inside. So it's a way to have versions almost like on a virtual machine, and in a way also it works very similar like GitHub, like with this kind of commands to build your image, your Docker image, to pull and push from a register where these images are stored, and then you can also just fetch one and run, like fetch the image with FreeSurfer version 5.3. Just fetch it, it gets into your computer, and then you run it, and you're sure that that version is nobody touched it. It has exactly the environment that you defined before. So in a way, with the Docker and with containers, is a way to have almost like code or executable code handle as data that you can also store and move around. So instead of, it's an opportunity to bring the code to the data instead of the other way around, right? So there's several advantages there, like you can version and share these executable tools. These executable tools also, like the other interesting aspect of containers, is that there's these the different execution environments, or container managers, that basically what, like on the bottom of the image, you can have, for instance, a container that has for morphology, so that has installed ants, that is already compiled, that has a specific version, some certain libraries, and other DICOM to Nifty and other kind of things there. You can have another container that has MRTrix pipeline, configure with a Python script inside that gets an input and has a bunch of things, and using MRTrix, and then it creates cryptography, for instance. So you can have these two containers, and in one single virtual machine, you can just tell the virtual machine, okay, start running ants container, and also in parallel run this other container with MRTrix and these other things. So these environments, like Kubernetes and another execution like frameworks, makes it also very easy that it can scale. So you could say, I want to run, like with Kubernetes, just run 100 containers like MRTrix and with all these inputs, and then they would scale automatically. So you don't need to worry about provisioning or turning on and off machines or virtual machines to accommodate your needs of processing, like for the different studies or different images. So that's these execution environments. And the thing that then we add associated with this is also we created then the platform, the QMENTA platform, that combines a data management system, so like a database and like storage. So then we can receive, users can easily store and manage DICOMs and hundreds and thousands of records of patients or subjects that have multiple files and multiple DICOMs inside. So to easily manage that, but in parallel, then there's also this engine that manages and runs and executes the tools. So then it becomes very easy that combining both, you can just have in your project, say 100, like 100 diffusion subjects, like with 100 subjects with DTI data, for instance, it's stored there, and then you could have an execution like a tool with the SDK. So like you can have in a Docker one tractography algorithm, you would plug in another tractography algorithm, and then you can just say to the platform, okay, to these 100 data sets that you have there, run tractography algorithm 1 and run tractography algorithm 2. And in a couple of hours, everything will be calculated because the execution engine will then just get the respective files, iterate through everything, scheduling the different pods and different Kubernetes virtual machines, and everything will be calculated. When they are done, it will store back the results of these algorithms. So like it takes out all this complexity of scheduling and dealing with data, moving data around, and having code and GitHub and versions and parameters, like makes it all, like connects everything. So then you can really get simple workflow from receiving data, from getting data, like even that comes from Apache or from wherever, to have that, then start launching a workflow that would, for instance, convert the income to Nifty, launch then another Docker that would do the ants cortical segmentation, and we'll do then a matrix, we'll do tractography, and then combine the results of both and do a connectome. So you could easily start doing these things, and everything is also scheduled automatically behind the scenes. So how everything fits together. So what I meant like with the platform and the SDK, so just give like not even a demo, just some screenshots. Like the platform is just accessed through the web. Everybody can just create an account. Like what you see here is the part of data management. So like here, every row here corresponds to a subject. Like this is, if I'm not wrong, like the Oasis data set. So you have here subject 1, 2, and also even have longitudinal data with the sessions, like different time points. Associated with each one of these subjects, if you would like right click and show the files, you would see inside the different DICOM files or NIFTs are the different files that are associated with this subject and time points. You can also have metadata, so like things that normally you would capture from ECRFs or from like RedCap or other things, like normally things that you keep track of on an Excel, you could also easily associate to the images. And then, so that's for the easy aggregation. There's a couple of things also to make sure that the data is really anonymized when it's stored, that it checks also like if the protocol, the imaging protocol is respected or not. So if the study is supposed to have, can define a T1 with certain resolution, diffusion with the 80 gradient directions, and a couple of other things, it can check automatically when the data arrives, if all of that is correct, or if not, immediately labels the quality as not pass, something is wrong with it. So then ensuring that the quality is there, so like the data is complete and correct. And then you could launch, easily select one subject or all of them, 25, 87, doesn't really matter. And then select from this drop-down list, like what tool or which workflow you want to apply. So in the end, which Docker you want to run and apply to the data. In this case, like that's an example for CNX. CNX 5, but the Docker is version 2.4. So then you can also modify that. I'll go quickly with that because there's documentation now. I'll point to you. So like what happens behind the scenes, so like from the user interface where you select this patient 1, I want to run a tool A. What happens behind the scenes is like it will fetch the respective Docker that was selected by the tool, by the user. It will fetch from the registry, and it will then launch a very basic Python script that is the entry point for the Docker, like when it's executed. And that Python script is really like minimally just like this. It will start in this run method. The first part is just a way to tell it like, okay, download to this Docker, to wherever this virtual machine is run, where the Docker is executed. Like it will go here and say, give me the files that the user selected. With this input part, you need to worry about giving the files that have a specific name, but just like certain conditions, like give me the file that is labeled as T1. Then you launch your code, you launch your MATLAB or your Python or whatever, a matrix or a preserve, like whatever you put inside the Docker. And then when it's done, you just say, okay, now upload this and this and this file as my results. And then behind the scenes, the platform will make sure that the files are sent to here to execute, and then they are stored in another bucket, and everything is traced. So you can have multiple versions also of running your tools, applying these algorithms. So everything gets really nicely tracked and traced. I'm gonna bypass this. So like there's a couple of functionality, like what I said, like you don't need to worry about file names when you're attaching the inputs to the inputs of the Docker, but really what's more important, like these tags or modalities. I want a T1, I want a T2, I want T1 with a post contrast tag, or a diffusion or a DTI or hard disk. So like it helps to make sure that to avoid errors in fitting the inputs to the tools. And some neat things, so like you can choose which files to upload, so to store then as results of the analysis. There's also metadata, so the tool, imagine like CNX could also add automatically to that Excel or to that table that I showed you before, can also add the measurements automatically to that table. So then you can in the end just export as a CSV, or even with Jupyter notebooks, like interact and then run your group level analysis or your favorite like R libs. And a couple of neat things like for context to inform the user what's the progress of the how far it is. You can set progress like visually, that is displayed like it's 0%, 10, 20, 50% error messages, informations, like kind of neat things to keep the user informed what's happening, which is also very important. Then to commit and push. So back here, so with the SDK and the platform, it's very easy for developers to push and to publish their code, to distribute, to democratize in a way their computational tools. They are plugged into the platform, so then it's also very easy to run those tools into lots of data sets as part of a study. And then it makes it also very easy that then you can quickly download and effectively download like all the metrics, all the measurements for your study in one single like CSV, for instance. So then you can do the rest of the study. So it's very easy to get results, visualizing the web, get PDFs, so many cool things that helps in executing studies. Yeah, here I'll leave it for a bit, but like the slides will be shared in another place. So there's different like useful links, especially like for the other track, for instance, there was a challenge that we were also helping. There's like a concrete example, like how to build a Docker for, in this case, was some cryptography code with IPy, I believe. And so basically an example of how to use the SDK. There's more documentation about different methods here, about the library as well, about the API, some more examples. And part of the Brainhack, there's different challenges. So I would also like to just point out to this link, the QMENTA.com/Brain Innovation Hub. So that's the invitation link for a Slack channel where we are there. If there's any questions, doubts, ideas on the platform, or if you'd like to to try it out or test it out, or if there's anything related to the SDK and to the Brainhack, that's a place where you can find us and talk with us. And yeah, and that's what I wanted to tell you about, like briefly, and open for questions. Like I just pasted here the latest list I saw from the projects, and if there's any ideas or questions on how to how a cloud environment like this and the SDK could be useful to help with the hackers and with the different projects, maybe like the reproducibility one. So open to the ideas and how we can help you in getting the projects further.
Thank you, Paolo. And since this has been quite a hackathon in the hacker style. You are actually missing one that was put there this morning, so it's okay.
Okay. I just did it like, I know. So
no, it's okay, even because even the mine that it's the most recent one was last night. So chapeau for that. Thank you.
Yeah.
So anyone has questions, both from the other panelists and the attendees? For the attendees, of course, feel free to both use the chat and the Q&A, and we can address any question. Since I don't see any question yet, I can start. So what I wanted to ask you is if a random user that knows about QMENTA wants to try out a tool that it's released there on the platform, so the Docker file, the Docker is already ready and things like that. Is there like an amount of execution time that it's for trial or something like that?
So yes and no. So like anybody can just go to the website, like QMENTA.com, and like there's a sign in like button, so you can just create an account and to try it out. So like what we have is like the default, there's like limited, so then there's nobody that pretends to be a good person and then tries to hack and like just overflow the system. So like we have by default, if I'm not wrong, like 10 executions. So it's not really on time or compute time, just like running 10 times an algorithm. But that's just like the default like quota. But we are always open for just have a chat, and we can just change that and set like different limits. So it's really like I've been there, so like did my PhD in Eindhoven and like being in this field. So like it's we're very open to collaborations and like how to help to speed up and support research R&D, because I think we believe that by moving that forward, that's how we then you accelerate bringing these great algorithms to clinical care, to clinical trials, especially in then clinical care. And that's where actually as a company, that's where the money is, right? So like we are, there's no limits on time, mainly on the executions, but we're flexible and we have different ways to collaborate.
So one can potentially concatenate 100 subjects to run on free surf.
Yes, exactly.
Everyone heard. Let's go and run 100.
We do like we monitor, so but they creative ideas. So we all do these kind of things.
I see a raised hand from Marco.
I don't see that.
Hi. Yeah, hi, Paulo. Thanks for the great talk. I'm curious to know if the QMENTA platform could be advantageous for federated learning. If the field is moving towards that direction, especially because more and more algorithms are converted into deep learning versions. And it's essential, you cannot have a model that generalizes across data set. So the best way to do that is federated learning. So from your talk, I understand QMENTA deploy the model and just apply it. Is there a way to, get maybe my model to be trained on locally on the data set, and then you can send back to me the updated weights so that I can use your platform in a federated way?
Yeah.
Or are you thinking of going in that direction?
So. Yes, pretty much. So it's so there's, let's say, 2 or 3 parts of that. So one is that there's so we use Docker as a way to package these tools, and we also like create our own algorithms, like also like deep learning, so like training it and then deploy the weights and be an executable tool. The thing I didn't mention like in the details is like, yes, it's a cloud or a cloud first system, right? So like it's hosted in the cloud, like in different environments. But also that means that we are already, in a way, let's call it federated, in the sense that we are already hosting data and the execution in different locations. So like there's like a consortium, for instance, on MS, that there's multiple countries in Europe. Actually, the coordinator is in San Francisco, and one of the partners is in Germany. So like that data from that site stays in a data center in Germany, and it's run. So the Docker is actually run in a virtual machine, well, in a data center in Germany. You know, like the interface doesn't look like it's all unified, but effectively it respects the data like jurisdiction. For the part of like more like the next level of Federated is something that we're working on, and actually like with some collaborations where it's even more like with graph databases, for instance, like just today, actually we're talking about that. So like how to bring these Dockers or this training into the sites, right? Train it and then bring back the model so then it can go to another place. So it's something that we're working on, and I'm very happy to continue that discussion, because it's something that we are actively looking at and improving. Because, you know, as you well know, and everybody knows, like, you know, AI is nothing without good data and variability of data and more data and volume, but also different kinds, right? So it's very important. And then it enters all the regulations, jurisdictions, and GDPR and other topics. So it's very important that the future is going towards there.
Yeah, thanks. Yeah, I think the real power of a platform like the one you have built is indeed in this direction, is one of the best way you can exploit it, especially to make our model more.
Yeah, and it's something that now is a next step, and we have like great foundations. Also, like what I mentioned before, that is to be embedded or in a way integrated in workflows, right? Because then, for instance, we have like some applications that makes it easy to get for hospital sites to push DICOM data from their PACS or PACS compliant software. So then that gets anonymized, gets routed to the platform, checks the keyway, launch the algorithms, output the DICOMs, and then that can be fetched back and put back into the PACS, back to the site. So this kind of interoperable in and out of data, that's fundamental to then train new algorithms, and then when they are trained or that version is trained, then that it can be used by somebody else. So that's the next step.
Okay, people ask questions, because I can keep asking questions for a long time. So I don't know if it will be fun for all of you. So my next one is, during the Iron Track challenges, some people have updated some workflows on the platforms. Apart from that, do you have you started like some way to recruit people to share their containers also there, so they would be available for anyone, or it's something that it's still in kind of an experimental phase?
It's something that we're scaling more, like putting more focus there this year. So like besides the Iron Track, there's also the Memento challenge, Vanderbilt and others. Brainhack is another opportunity, and something that we want to do and more and more this year, to as a general idea, and be hosting a new webinar in March, right? So where like also like we'll be looking for ideas and projects and challenges that we can expand and have a way to people to create new tools. So yeah, that definitely. And there's with these challenges and like this kind of campaigns, let's say, like with challenges, hacks, that we're going to be more and more supporting. And besides like collaborations with centers and universities, where it's like concrete tools that somebody's developing and then want to distribute, and maybe for some clinical study or some trial.
Okay, so anyone else from the project leaders, thoughts, curiosities about how things can move forward? Not necessarily in these few days. If you, Marco again.
Well, I keep going as well at this point. Now, I was just curious to know, so you have different models in your platform. So if I'm a clinician, acquire some data, I can just use your platform to process it, right?
Mm-hmm.
But is there any control on which model I use on the data, or it's up to me?
Yeah.
So for instance, I use DTI with b-value 5,000, and that doesn't make sense. So is it, or I fit a kurtosis model with b-value up to 6,000? Again, doesn't make sense. Is that up to the user, or are you planning also to work with the model developer to put some constraints or guidelines on how to use?
Yeah, basically a bit of both, but essentially like the developer, whoever created the tool, there's a couple of things that you can also define. That is to define what are your inputs. So like the inputs in the sense like, I need a T1 and a T2 and a diffusion image with at least 50 directions. Okay, you can define that. You can define also how the results can be visualized, for instance, or how do you create a PDF report. So like there's a couple of things that is kind of on the power or domain of the developer of the tool. Because then what the platform does is like when a user selects a data set and says, I want to execute this tool, it will check if there's a match. So if it finds if in the input container there's actually, or if in the input bucket, so like in the input data, there is a T1 and a T2, but there's no diffusion, for instance, that will say like, hey, I cannot run this because there's diffusion missing. So there's like,
but if I provide a diffusion with only 3 directions, does it warn me?
It can, yeah. So like
the results is not, okay, depends how you.
Yeah, there's like tags, there's modalities and tags, and also you can use like DICOM tags and other things to ensure that. And even before, so like when data arrives to the project, to the study, you can also like, there's a protocol adherence, so like something that will check if all those parameters are correct. So then you already, even before you try to run a tool, it will already tell you like, the QC, the quality is not didn't pass because there's something missing or incorrect from what was expected. So there's different control points to avoid those kind of things from a user.
Yeah, I like it, because there is a control on the quality of the data, on the quality of the output, but it seems you also allow to have a control on the actual applicability of a model, which sometimes is overlooked.
Yeah.
Great.
Okay, so Paulo, Chantal was saying that she had a question, but she couldn't raise her hand, so now here she is.
I was just wondering about these GDPR guidelines and the opportunity to pool data with your platform, like what your experience is with that. As we had these discussions multiple times, but it's a bit questionable whether a brain scan can really be anonymized, and if you ever experience problems with that.
Sometimes it's a topic about if the brain images are actually identifiable or not, but we really just had one case, and actually in US, where there's like the requirement to actually deface the images. So not so much about the gyri and the aspect or the look, the morphology of the brain, but just the face in the images. So it's something that we solve that, or we mitigate that risk of like the private information or health information, not only by removing or stripping all the DICOM headers, right? Like patient information and other things. So like automatically, even before uploads, so like even before it leaves the firewall of a hospital, but it can also like deface the images. So then there's less risk of identification, and really not in EU, but in US, actually for kind of other reasons, but that was some concerns with some major hospitals in US. Just like the ultimate discussion, right? Like, can you identify somebody technically? Yes, but then because it's reasonable technical efforts to do that, that's where it enters like certain terminology in GDPR and HIPAA. So like we handle it by, especially by stripping out the DICOM headers and other things. And if necessary, can also like deface the images. And that's more really great efforts in ensuring the PHI for GDPR and for different multi-sites, European-wide consortiums and even collaborations with the US as well. So there's the discussion, but sometimes a bit more ultimate, going all the way to the...
Yeah, so data pooling is also something that the platform provides if the users agree to share data, or...
Yeah, exactly. Okay, data pooling, yeah, or data lakes, yeah. So that we have also already available if somebody could use like different like open data sets and different initiatives out there that are sharing data, like to there's different licenses, but like we continue that license. And if somebody wants to share or make some pool of data available to others, that's also like totally really want to help with that, because that's how we were doing, for instance, for COVID. And it's not the brain, but like for COVID, we're like helping to centralize and collect different data sets out there. So then like developers could have access to a wider pool of imaging data. So yeah, definitely, yes.
No, I'm not sure on which point I want to follow up, because both Marco's and Chantal's points had interesting things. So let's go with the previous point, Marco's points. So basically, when someone needs to introduce these reasonable limitations in the workflow, so like the examples that Marco made, it's is it on the developer, on the platform, or on the user? Well, of course not on the user, because the user won't know that there is a limitation, but is it then on the developer? And if it's so, should it make sense to like write some guidelines in this sense?
It's essentially on the developer. So like so the tool, so the Docker, like the executing part, the code, fetches, just says download or give me whatever you have that is T1. So like it at that point when it executes the Docker, so when it starts that Python code, you already come with with a chosen subjects and with images that were uploaded. But when the developer is building the tool and then integrating, so like registering it in a way in the platform, like you define the name, what's the Docker repository, credentials, what's the entry point, like what's the first script that it will start, and also you define what are the input parameters, right? So like, and that's like, there's like, we have the documentation, there's like a little kind of language, or not a language, but like a way to define that my input, my expected input is this and that with these characteristics. So in that what's used when the user, on the side of the user, he chose a data set and then says, I want to apply this Docker tool. It will check that if what is labeled in the platform as like the images that are available, if they match what the tool is requiring. So like it's up to the developer following certain guidelines and the documentation, like certain characteristics that we have defined. And then so that's part of the whole kind of imaging workflow, where part of when we also have when new data is uploaded to a project, there's the first thing that actually happens is like it launches another Docker, right? And another execution piece that actually will go through all these DICOMs or what was uploaded and anonymizes it or checks if it's anonymized. That also like classifies. We have an imaging classifier that goes and labels. This DICOM is a T1. This DICOM sequence is a T2. This is like a T1, but also adds a tag gadolinium. So there's a piece of code that organizes the incoming data that can be fixed or modified by the user as well, or whoever uploads the data. And if also check like the protocol or checking the quality, and then it can launch the tool, and it will use what the developer defined as the input and what was classified as what are the types of images in the image. Does that make sense?
Yeah, no, it does. No, it's very interesting, and I think that it already basically expect some of the things that will happen in the wild, and it's a good thing, because you don't want to have something then
exactly.
you have the user that don't understand what is happening and is angry because it's not running.
Yeah, and there's also like other things like to minimize like the choices, right? So like in a study, like when you invite, maybe like you created your tool and there's some data uploaded, and then you invited a clinician to run and actually like look at the images and the results. So in that study, you can also configure that project to just have available one tool and the version that you want. That's the official one. So then there's no choice, even, right? Or you will just make it available that in that study, it's only to run a free surfer and your tool, and that version and that version, and that's it. And then all of that can be configured behind. So then you also ensure that, you know, with each version was all the results were calculated when, like all the aspects of traceability. So like all of that it's make things easier.
And since I don't see any raised hands, to follow up instead Chantal's points, basically, since you mentioned that you didn't have issues with like the EU or just one in the US, you wanted to add something?
Yeah, I mean, issues that there are challenges, but they were solved. So like in the sense that like we are doing things that so the issues is in describing and clarifying what are we doing about GDPR and about anonymizing. So with that, we after these kind of like checks and from the like BPO or data protection officer and other things, so that we show how we are handling data, or how is data handled with that respect, and then it's fine. So it's not issues like, not a blocker.
Okay, yeah. No, because I heard from a colleague of mine in Germany that basically once had a very hard time sharing some data, because even if the MRI data were defaced, the ethical committee wanted proof that basically even for him, when looking at the defacing data, he was supposed not to recognize the subjects. And now these were patients that were, there were a couple of case studies, so most probably he would have recognized those. Have you ever had very edge cases like those?
Heard or less potentially, but like there's it goes into the edge cases of like, if for instance, like if there's rare diseases and then there's just a couple of patients actually, so it's, if it's about that disease, the pool of you pretty much guess that is one of those 5, so it's, or if there's like location, so that's where it gets it. So it starts to enter the edge cases of like GDPR, because if the pool is like, it starts to be narrow, too narrow, then there's the difficulties. Like with Germany, like in particular case of Germany, was more the it's combined, but not so much about the GDPR aspects, like about the privacy, but like the jurisdiction. So like the data from Germany would not leave the territory, right? But then with the like with ERB and GDPR, like what exactly? So actually, like another consortium, like the challenges is more like the logistics, the data transfer agreement, like what are the variables available? Are they potentially identifiable or not? And if there's something that is really needed, like age, like the age of the patient instead of a birth date, then that's converted at age as scan. There's also other guidelines, like if it's like above, like people above or older than 90 years old doesn't even say what is that the exact age, but just as a pool that is above 90 years old. So like things to kind of make it less obvious that who potentially might be that person. And as you do those things, it's more of a process, like in describing and explaining that. But like that edge case, we didn't experience, like not yet. And it's troublesome sometimes, but it's more of like of the data transfer agreements and like explaining and describing all of it. But yeah, we have different consortiums in Europe, in US, clinical trials as well. So figure out many of those things.
So once again, other project leaders and of course other attendees, questions, curiosities on the presentation and what we have been saying in this last half an hour?
It's just I'm not checking my so like if anybody has further ideas or just send me an email. Yeah, Paulo at QMENTA or join the Slack. I'm also like in the Mattermost, so you can find us in different places. But happy to talk about something more in particular about the project or further ideas to take it further. Don't hesitate.